Hi guys, we're going to begin chapter 10 here. This is a new way of me recording my videos. So if you have any strong opinions one way or the other, if you'd like to respectfully reach out to me and share them with me, I'd really appreciate it. Just trying something new. But it's a good section to do this because there's so much writing in section 10.1. So there's no need to watch me write a lot. I'm going to give you the highlights here in this video. And if you want to see the details in terms of what you actually write, check out the scans and structure guide on Brightspace. So with hypothesis testing, it's the reverse of confidence intervals. Confidence intervals takes a sample and makes a conjecture about a larger population. Hypothesis testing, there is already a conjecture about a larger population we believe is true, and it's not a range, it's a number. And we take a sample to see, is it really true? Do we think there's evidence to suggest it's not what we thought? So those steps are first to make a statement regarding the nature of the population. The statement being typically, something is or thought to be. And then you're going to collect evidence through sample data to see, is there, a lack of plausibility to what we assume to be true if we have a sample like this? Or does the sample support what we thought was already true? What we think to be true is known as the null. That's capital H subscript 0. It's always a statement of equality. It's a statement of no change, no effect, no difference. That'll be scanned and posted. And it's always assumed to be true unless proven otherwise. How you prove otherwise is you get evidence in an alternative. And the alternative will always be a less than, greater than, or simply not equal to statement. And it's like, we think, if you think something's not true, if a number is not true, it's like, well, is it less or greater than, or just you don't know? So the two-tailed test is that not equal to. That's where the alternative is not equal to. The parameter, meaning mu or p or sigma for standard deviation, is equals. A left-tailed test would relate to the less than. A right-tailed test would relate to the greater than. The left and right-tailed test are one-tailed tests. The two-tailed test, the not equal to, is the only one of those we have. So setting up the problem is sometimes, the most challenging part. We have here the assumption that this particular antibiotic causes 2% of kiddos to have a headache as a side effect. As a decimal, that's 0.02. Now, the alternative would be something compared to 0.02, whether it's less than, greater than, or simply not equal to. And they're saying this new drug, the alternative, it might be more than 2%. And because this is a left-tailed test, or I'm sorry, right-tailed test, because it's testing to the right, that'll be scanned and posted. Now, Chevy here in Miami, they have a car that the value is thought to be 59,083. But in Miami, Grant, I believe, thinks that it's different. Might be less than, might be more than. He just wants to see, is it actually that? This is our two-tailed test, and that'll be scanned and posted. So if you've been around, you know that if we have a right-tailed test, a two-tailed test, and a left-tailed test is coming up, and that sure is. And this is a standard deviation situation because it's variability. And the variability, or sigma, is thought to be 0.23. The alternative is going to be sigma compared to 0.23. And in this case, it's saying, is it less? Do we have a better machine? Is there less variability? Typically, we like less variability when it comes to calibration. Now, there are two ways you can have correct hypothesis tests. And you might be like, why are there 4 outcomes then? Well, there's 2 ways you can make a mistake, but that's just life. That happens all the time. But the first way you can is to reject the null when the alternative hypothesis is true. So like with the antibiotic example, you might reject that this particular antibiotic gives 2% of kiddos headaches because the alternative is it's actually more. Or, maybe the alternative is not true. You don't reject it. You don't reject the null when the null is true. It's like, well, we tested a new antibiotic. It doesn't seem like it's more than 2%. So don't say it's different. Don't say it's more than, it's still 2%. Don't reject it. The null is true. Now there's 2 incorrect, okay? There's 2 incorrect decisions, and it's when you do the opposite. So if the null hypothesis is true and you have a mistake there, the mistake would be that you rejected the null and you shouldn't have. This is known as a type 1 error. If you do not reject the null, you say, okay, the antibiotics still only cause 2% of headaches in kiddos, so we don't reject it. But here it actually was more. Time proved it was more. That would be an incorrect decision, and that's known as a type 2 error. we're going to have likelihoods of getting a type 1 or type 2 error, and they're related. They're complements of each other. Okay, so here's a chart of that. It's a good thing to have handy when you're doing the homework. With that Medco pharmaceutical example, if you recall, we had a null, the statement of equality of 2%, and then we're testing, is it greater than? A type 1 error occurs if we reject the null when it is true. So the null was it equals 2%. The alternative was that it was more than 2%. A type 1 error is where we say, nope, there's evidence to support the alternative, but uh-oh, the null was actually true. In other words, the new antibiotic sorry, it's having trouble writing. Oops, just took a while to catch up. Only causes headaches in 2%. See, this is why this is a good section for me not to write. Check out the scanned. That's pretty icky. But I do want to talk through and see it. The type 2 error is the opposite. The type 2 error, you have your null, you have your alternative, and this is saying we don't reject the null, we accept it, but the alternative was true. Okay, so this is when we say, uh-oh, we said that the alternative, we said the new antibiotic only causes 2% of headaches. But in fact, it is more. And again, I apologize. That's going to give the most important part here I want you to see is the level of significance is the probability of making a type 1 error. So if the level of significance, the probability of making a type 1 error is 0.05, this is the probability of type 1. There might be questions where what's the probability of a type 2 error, and they're not going to give you that explicitly. The probability of a type 2 error is beta, and it's 1 minus the 0.05 or 0.95. It's kind of like the confidence interval thing. All right, so 10.1 leads up to where we draw conclusions. They're multiple choice, but it's very important you read them. If you glance them, they're going to all look the same. I actually think, usually in statistics, I mentioned this in the 10.2 video, usually in statistics, as we go at section to section, the sections get more challenging. But I actually think this is one of the unique examples where 10.1, just learning this, can be much more challenging than actually doing the problems. All right. Sorry. It's just, for whatever reason, I'm going to erase that. I can erase these. I'm having trouble for whatever reason. Maybe it's because I've been on here too long. It's getting more sensitive. But let me try one more time. So if your decision is to reject the null, the conclusion that follows is that there is enough evidence to support the alternative. It's one or the other. You're either supporting the alternative or the null. If you don't reject the null, you're saying there's really not, the sample evidence is not very exciting. The alternative doesn't have any pull. So remember, with this Medco pharmaceutical, this antibiotic example, what we think is going to happen is 2% of kiddos are going to have headaches as a side effect. We're testing, is it more than 2%? If you reject the null, you're saying evidence suggests more than 2%. And there's going to be a fancy way of going through that. If you don't reject the null, you're saying evidence does not suggest more than 2%. So check out the scanned version of these. Reach out if you have any questions. I'm here to help. The homework is a great way to work through this. Thanks, guys.